Hello everybody, welcome into the Fallout Shelter. I want to thank you for joining us today. I'm going to bring you some information about tokamaks and lithium today. I heard a larger channel, I don't remember which one it was, the other day questioning the guarding of lithium. We've all heard of our troops protecting the lithium mines in Afghanistan, and we wonder why we would be doing that for batteries and things of that nature. Well, we're not doing it for batteries and things of that nature. I found some information on the lithium ITER Tokamak that I would like to bring you today. If you're not familiar with a tokamak, it's basically a neutron star built on Earth to provide power. It is a nuclear reactor built like a star. Richie from Boston does an excellent job of explaining what the tokamak is. You need to check out his videos on that. One's being built right down the road from CERN. But what I found about the importance of lithium is what we'll stick with today. What I would like to show you all today is the lithium tokamak experiment. This is from pst.ppl.gov. It's the People Publications. The lithium tokamak experiment and its predecessor, the current drive experiment upgrade, are devices dedicated to the study of liquid lithium as a plasma-facing component. One of the attractive features of a liquid lithium PFC is that it virtually eliminates recycling or the reintroduction of cold gas back into the plasma from the vacuum chamber walls. This is because lithium has a high chemical reactivity with atomic hydrogen, which is then retained in the PFC. Flowing liquid lithium can also potentially handle the higher power densities expected on fusion reactor walls. In addition, lithium has a low Z, so radiation losses should be reduced if there is any sputtering from the plasma-facing component. All major tokamaks have obtained their best performance under low recycling conditions. If a fully non-recycling wall can be achieved, theory predicts that the basic nature of magnetic confinement will be changed. The temperature and density profiles and plasma current distributions would potentially eliminate deleterious plasma instabilities. Furthermore, the transport mechanisms causing the loss of energy in particles would be reduced, and plasma with higher energy confinement could result. So basically, lithium will become the new energy fuel. That's why it is so important. I know many of you have seen it, and I don't have the way to pull it up. I don't really know how to do that right now. John Brennan, the CIA director, when he was speaking of stratospheric aerosol injections to the United Nations, he made a statement in there where he said, while we make the transfer from fossil fuels. I don't know what all of that has to do in the big picture. I'm trying to put the big picture together. But that statement he made really sent chills down my spine. We're having a complete change around. We're not just changing the terraforming of Earth. We're going to change the way we're producing energy. And that always seems to become an unstable situation here. The first test of a large area liquid PFC had a toroidal tray on the bottom of the vacuum chamber to contain the lithium. Even with this partial non-recycling PFC, major improvements in plasma performance were obtained. Impurities were reduced and a dramatic improvement in energy confinement was observed. To achieve more complete non-recycling PFC, the CDXU vacuum vessel was disassembled for the installation of a heated inner shell inside it. This was a major step for the conversion of CDXU to LTX. The LTX is the lithium. The shell was fabricated out of 3/8-inch copper sheets, which had a stainless steel liner explosively bonded to it. The stainless steel plasma-facing surface of the inner LTX shell will be coated with lithium between shots using an electron beam evaporator. By keeping the shell temperature above the melting point of lithium, 90% of the LTX PFC area will consist of non-recycled liquid lithium. And that's a picture of that right there. And then we jump to right here, fueling the fusion reactor. 440 blanket modules cover the inside of the vacuum vessel and directly face the hot plasma. Certain modules in ITER will be used during later stage operation to test tritium breeding concepts. This is just a little, I'm not going to read the whole thing. It's a little way of how it works. In the deuterium tritium fusion reactor, high energy neutrons are released along with helium atoms. These electrically neutral particles escape the magnetic fields that confine the plasma and are absorbed by the blanket covering the surrounding walls. If the blanket modules contain lithium, a reaction occurs. The incoming neutron is absorbed by the lithium atom, which recombines into an atom of tritium and an atom of helium. The tritium can then be removed from the blanket and recycled into the plasma as fuel. Okay, I'm going to leave the links in the description to all of these things. Some pictures of ITER, neutron star, Tokamak, lithium fueled reactor on Earth. I just thought I would share this with you today. I had heard that question asked, why is the lithium so important? I kind of got to looking into that. It made me think. And this is what I found. I found that lithium will probably be the new fuel of energy. And this is the way that it will be done. So I wanted to share this with you today. I hope you get this information and you see the importance of it and what's going on. If you enjoy this type of information, I ask you to click that like button and subscribe if you enjoy it. You can join us at, we stream this stuff live on DLive at DLive.TV/Fallout Shelter. And we also have a Sky sharing and a chemtrail sharing and then just a general sharing Discord page. All the links are in the description and on the screen. I appreciate y'all coming in and joining us today. God bless you and have a wonderful day.